Example 7. Woo woo! All right, f of x equals negative base 2 to the power of x minus 5 plus 4. So students, if it's a base of 2, your parent function must start with the base of 2 raised to the x. And remember, exponential functions, y'all, the domain is all real. So that means we can pick negative numbers and positive numbers, whatever we want, okay? So 2 to the negative 2, it looks like this, 2 to the negative 2. So we have a negative exponent, we bring it to the denominator, so it's now a quarter. 2 to the negative 1, it's a half. 2 to the 0 is 1. 2 to the 1 is 2. 2 squared is 4. Those are the inputs and outputs of your parent. Now x plus 5, because h is 5, so a is again negative 1, h is again 5, and k is the same as the previous examples, 4. So negative 1y, negative 1 times y plus 4. Remember before in your exponential notes that for the parent function, you always have a horizontal asymptote at y equals to 0. With k being 4, y'all, that means you now have a vertical shift up 4. So you can go and straight up graph your horizontal asymptote right away, which is y equals 4. Okay, that means your graph should either be below or above that line. So let's change all of the x's first. Negative 2 plus 5 is 3. Negative 1 plus 5 is 4, 5, 6, and 7. A quarter times negative 1 is a negative quarter, plus 4 is 3 3/4. A half times a negative 1 is a negative half, plus 4 is 3 1/2. 1 times negative 1 is negative 1, plus 4 is 3. 2 times negative 1 is negative 2, plus 4 is 2. 4 times negative 1 is negative 4, plus 4 is going to be 0. So let's plot. So 3 in x and 3/4, okay? Now these 2 points, 4 and 3 1/2, my pen is like super fat, so that's why you normally see these 2 points of mine are close to each other. 5 go up to 3, 6 to 2, and 7 is 0. Remember, your exponential functions, right? The domain is all real, so make sure we go left and right indefinitely. So negative infinity to infinity is the domain. This is your expo function. The range, as you can see, is negative infinity to the highest y value. Remember, your horizontal asymptote is at 4, so it gets closer and closer. And we can't touch the horizontal asymptote right now, so we're going to say it's not inclusive, so that's a parentheses. Now, y-intercept is when x equals to 0, so we're going to do some algebra for that. So y-int f of 0, sorry, I need to plug in, f of 0 equals negative quantity 2, 0 minus 5 is negative 5, and then plus 4. So this is going to be negative quantity, and we're going to go, okay, well, that's a negative exponent, so I'm just going to go 2 to the 5th to the denominator. Okay, well, 2 to the 5th is going to be 32, so this is a negative 1 over 32 plus 4, so that's going to give us 3, positive 3, and 31 over 32, okay? So we can fill in 0, 3, and 31 over 32. Now, students, this does make sense, right? For the y-intercept to be super close to your asymptote. So that's 3 and 31 over 32. That's extremely close to 4. And again, remember, we can't touch the asymptote, so that makes sense. That's where it should be. Let's go on to, whoops, I meant example 8 down here. So 8, well, log and exponential, they're so closely related, right? So we are going to, again, have, example 8 gave us f of x equals negative log base 2 of x minus 5 plus 4. And a is negative 1, h is going to be 5, and k is going to be 4. Now, the base of this log function is 2. So students, make sure you guys start out with the correct parent function base, and that's log base 2 of x. Remember, an equivalent equation of this in exponential is 2 to the y equals x. So you can use your exponential, if you don't remember, okay, again, oftentimes, right, we don't really have things memorized, and we don't really technically need to memorize the inputs and output of parent functions. So for this, we will be picking values for y, okay, because it's easier to use exponential to plug in. So to get x value, we go, okay, well, 2 to the negative 2, again, we have seen this quite a bit, right, is a quarter. 2 to the negative 1 is now a half. 2 to the 0 is 1. 2 to the 1 is 2. And then 4. Now I'm just going to go to the right side and make a transform table. X plus 5, negative 1 times y plus 4. And use my parent function. I'm going to pinch it in so I can see all of the parent's input and output. Let me make it, there you go. So my parent, the first input is a quarter. So first x value is a quarter. So quarter plus 5 is 5 and a quarter. A half plus 5 is 5 and a half. 1 plus 5 is 6. 2 plus 5 is going to be 7. 4 plus 5 is going to be 9. Not too bad, right? Negative 2 times negative 1 is 2. 2 plus 4 is 6. Negative 1 times negative 1 is 1. Plus 4 is 5. 4. 1 times negative 1 is negative 1. Plus 4 is 3. And then looks like we have a pattern of 2. Let's plot those. 5 and a quarter. Let me make it a little bit bigger. 5 and a quarter. 2, 4, 5. And go up 6, 2, 4, 6, somewhere like there. 5 and a half, go up 5. Again, these two dots are usually kind of close to each other. 6 is 4. 7, 2, 4, 6, 7 is 3. 9 is 2, so it looks like this. And do you guys remember your log functions would have a vertical asymptote? Yes, so it's going to be at h equals to 5. So this is your vertical asymptote, okay? Because it translated 5 units to the right. So we're going to go, wee. So if we were to keep on going, it goes like this, okay? But I didn't want to cut out my ABC spot there. Now, the range, which is C, is going to be all real numbers, okay, from negative infinity to infinity. Your domain, which is part B, non-inclusive, the smallest x is going to be getting closer and closer to that h value, which is 5, and it goes right forever. Now, this is your logarithmic function, okay. Log for short, so logarithmic function. D is going to be your y-intercept. Can you guys see, since we have moved the function 5 units to the right, we will never, ever, ever touch the y-axis. Therefore, we do not have a y-intercept. All right, one last example. Woo, woo. So guys, this is your last example. A is negative 1. H again is 5 and K is going to be 4. Then the parent function is the reciprocal. So y equals 1 over x. And this is where we are going to have two asymptotes, okay? So negative 2, negative 1, 0. That's never going to happen for the parent, 1 and 2. Oh, you know what? I forgot negative half. So negative half, 0, positive half, 1 and 2. So negative 1/2, negative 1, negative 2, not happening for the parents, 2, 1.5. Okay, so now I'm gonna, actually I have enough space to make my transform table right here. Negative 1 times y plus 4, all right. So negative 2 plus 5 is 3, 4, negative half plus 5, that's 4.5. Remember, we have asymptotes both at 0 for horizontal, at 0 for vertical. So if we used to have an asymptote at x equals to 0 and we shifted 5 units to the right, so now we would have it at x equals to 5. So that's your vertical asymptote, which is x equals to 5. We used to have a horizontal asymptote at 0, and we shifted up 4 units, so now it's y equals 4. So this asymptote is here. So this is y. Oops. Let's write it right over here. All right. Okay, now 0 plus 5 is going to be 5, but that's one asymptote. A half plus 5 is 5.5. 1 plus 5 is 6. 2 plus 5 is 7. Those are all of the x's, okay? Now, negative half times negative 1 is now a positive half. This is your first y value. A positive half plus 4 is 4.5. Negative 1 times negative 1 is 1. 1 plus 4, that's going to be 5. Negative 2 times negative 1 is positive 2. Plus 4 is 6. Now, the next, if you count down, it's the next y value after your undefined is 2. 2 times negative 1 is negative 2, plus 4 is 2. 1 times negative 1 is negative 1, plus 4 is 3. Half times negative 1, y'all, is going to be a negative half. Negative half plus 4 is a positive 3.5. All right, let's plot. 3 go up 4.5, so 1, 2, 3. This is 4.5. So right there. Come on, right there. Come on, make a dot. Why is it? Okay, there you go. So 3, 4.5. 4 go up 5. 4.5 go up 6. So there you go. So here's your one side of this reciprocal function. Then I have the right side as well. On the other side of my vertical asymptote at x equals to 5, 5.5 is now 2. Oh, that doesn't look like 2. Sorry, it's right here. 6 is 3. And 7 is 3.5. So those are them. All right, beautiful, isn't it? So this is your reciprocal function. Okay, your domain is going to be from negative infinity all the way to that vertical asymptote at 5, union with 5 to infinity. Your range is from negative infinity all the way to that horizontal asymptote at y equals to 4, union that from 4 to infinity. Your y-intercept, we do have some, but you can't eyeball that. So let's find it manually. Are you ready? So y-int is when x equals to 0. So f of 0 equals negative 1 over 0 minus 5 is negative 5 plus 4. So negative 1 divided by negative 5 is a positive 1/5 plus 4. So that's going to be 4.1/5. So that's super close to this horizontal asymptote. So that makes sense why it would be 4.1/5. So let's fill that into our letter D. So 0, 4.1/5. Woo, woo, y'all, we are done.